Hey guys, so this week we are going to look at the FFT algorithm. Like FFT is an algorithm which is used to compute the DFT. So we'll be calculating the DFT with the help of FFT. So for that we have to first import the libraries and packages from the FFT. That is Arduino FFT equal to this one, samples, all these things constant like we'll be using FFT.compute in the middle of this for FFT forward and both FFT reverse for both forward FFT and inverse FFT. So first we need to import this. For that we have to go to this libraries, like we have to download the first library and then we have to go to examples. Here we can see Arduino FFT. From this we can copy this command Arduino FFT is equal to Arduino FFT as include Arduino FFT.h. So after importing these commands, now the same process again. So we have taken this number of samples for 12 and now the samples are this one. Here we have taken 10 heads and 30 seconds, so that will give us 300 samples. But we have, for implementing this FFT algorithm, it should be in the number of samples should be in the power of 2 power m. So we are making it to the nearest possible 2 power m, that is 512, that is 2 power 9. So like these number of samples are 300 samples, and that is with the zero padding it can be equal to 512 samples. So sampling is equal to 10. We imagine, like we are taking all these values into real values, and the imaginary also taking 0, and I have taken the matrix for magnitude. Okay, so leave this thing, this is not needed. I taken two integers, max value and L value. So after this done, now so I have taken serial dot begin of 1,50,200 and serial dot print of ready, just to make sure that like to print for the sake of completeness, that's it. So now I'm taking FFT.compute. This will give us the fast Fourier transform in the forward direction, that is just in the forward direction. This will compute it, and again it will store in VReal and VMag. Like it will compute the fast Fourier transform of VReal and it will again store it in VReal. It will compute the fast Fourier transform of VImaginary and it will again store in VImaginary values. Now I am taking the magnitude of that FFT square root of VReal star VReal plus VMag star VMag. This will give us the magnitude. From this we are calculating the, like now we have the aim of our experiment is to calculate the respiration rate. So the taken samples, it is both a mixture of PPG signal and the respiration signal. So now we have to separate that respiration signal from this. So in order to do that, first we have to calculate the respiration rate. For that, we already know that the respiration frequency of the human lies between 0.05 and 0.5, that is k into fs by n. Already we have seen this previous week. So k into fs by n lies between 0.05 and 0.5. From that we'll be calculating the k1 and k2, and in this k1 and k2 we'll be finding the maximum value. For that maximum index we are calculating the respiration rate. So now that maximum index is L. For that L we'll be calculating the maximum respiration rate. Now the respiration rate is k into f, again k into fs. Here the fs is 10 heads into 60 divided by 512. This will give us the respiration rate. Now I'm uploading it. Yeah, it is about to upload. We have to change this here. 16. So that is our respiration rate. Done. Okay, now moving on, we should plot the respiration signal. So to plot the respiration signal, we already find this window right from k1 to k2. So except that k1 to k2, we'll be making all other values as zeros, and we are calculating the inverse fast Fourier transform of this window. So for int I equal to 0 to I less than 512, if I less than 2 or I greater than 20, that is k1 and k2, we'll be making other values as zeros. So now we are left with only with that particular window value. For that we will calculate the FFT reverse, and for that we will be plotting the respiration signal, that is serial print of V real of I. So this gives us the only the separated respiration signal. So I'm uploading it. I have already calculated the respiration rate. You have seen that 16. Now I'm plotting this respiration signal. So the input signal, from the input signal, if we separate the only respiration signal, it will be looking like this. So with the help of PB signal, you can calculate, like with the help of this FFT, you can calculate both respiration and heartbeat pulse rate. Thank you.